We looked at the logical NAND gate, which is the same as an AND with a NOT after it. We take the output of an AND and we do the inverse of it, so NOT. And we have the similar thing for a NOR gate, which is essentially an OR gate with a NOT after it. And that's why it's represented with the same symbol here, but with a circle after it. And it's the logical inverse of the OR. So when we have 0 at X or Y, we have a non-signal. But if we have true, if we have the switch on in Y and the switch on in X, then we have no symbol here, no signal. The only time we have a signal is when both are off. And as we can see from our truth table, a NOR is you only have a signal when both X and Y are off, and we have an on signal. All other combinations of X and Y equals a 0 on the light. And finally, we will consider combinations. In this combination, we say X and Y or Y. So we have the output of X and Y coming here, and then we have Y coming here. So this can be read X and Y or Y. And here I have it labeled. X and Y give me this, and this section here equals X and Y or Y. And let's try this. We have a signal on X and Y, so the current runs through. This is true or this is true. For the light to be lit up, we only need Y to be true because we've got an OR here. For the current to come on this side, we need both X and Y to be true, and it will come through here and the light is lit up. So this is a combination. We can have any combination we want. If we wish, we can take the inverse of this by deleting the connection and introducing a NOT. And now we've introduced a NOT, and we draw this annotation as saying the inverse of X and Y or Y by putting NOT at the end. This section is logically the same as inserting a NOR gate here. That's a NOR gate. So this is the equivalent of the OR and the NOT. And let's look at the truth table of X and Y or Y. In this case, we have already calculated X and Y here, and we have Y here. So we will OR them. So we'll have a signal of either one of these equals 1. So we have 0 and 0, 1 and 0, so we get a 1 because we're ORing this. And we have 0, 0 here, and we have a 1 in here. So the truth table is 0, 1, 0, 1. Here's the first condition, 0 and 0, X and Y are 0, and we have no signal. No signal on the output. Here we have a 1 on Y and a 1 here on the X and Y, a 0 here, and we have an output in this example here. 1 on Y, true on Y, false on X, and we have an output which equals true. 0 on Y, 0 on the X and Y, and 0 on the output. 0, 0, 0. True on Y, true on the X and Y, and true on the output. X, Y, and true on the output. This has been an introduction to logic gates and truth tables.